Kelly Purdue. I'll take you from the assembly line to the front line. Welcome to GI Factory.
Nice.
My mission is to take you inside military factories to learn firsthand how today's combat gear is really made. In this episode, we visit the Ohio factory that puts extra protection on the military's workhorse vehicle, the M1114 up-armored Humvee. The work they do saves lives, and they can prove it. We explore the South Carolina plant that builds the M16, the gun U.S. fighting forces have carried for 4 decades. And we tour the Pennsylvania facility that hand-builds the helmet soldiers wear into battle. I had no idea how complicated it is to make this high-tech marvel. It's all coming up on GI Factory.
Welcome to Fairfield, Ohio, home of Armor Holdings. I'm standing in a sea of chassis of M1114s, Humvees, and in just 24 hours, Armor Holdings can take this chassis and turn it into an up-armored Humvee.
This plant, just outside Cincinnati, is going full tilt, producing 30 battle-ready vehicles a day. Vehicles that keep troops moving. Vehicles that are truly part of military history. What the Jeep was to World War II and Korea, the Humvee is to today's fighting forces. Stronger and far more stable than the Jeep, the Humvee is the primary light utility vehicle, perfect for patrolling or hauling supplies. It is an essential part of almost every mission, and a staple on nightly news. Like almost everything in the military, Humvee is an acronym. HMMWV stands for High Mobility Multi-Wheeled Vehicle. The vehicle can be modified for any number of uses, from medical evacuation to transporting heavy items. Whatever the need, the Humvee can deliver. But Operation Iraqi Freedom brought a brand new set of hurdles to the Humvee. Attacks from rocket-propelled grenades and improvised explosive devices, or IEDs, meant the Humvee needed more protection. In military speak, they needed to be up-armored. The assignment was given to Armor Holdings because they have a long tradition building armored cars for the commercial market. Their consumer division caters to athletes, royalty, and rock stars. But the bulk of their business is the up-armored Humvee. It's a job the 580 folks here in Fairfield were happy to take on. Production manager Ron Carson was my guide through the factory. First thing, he showed me just how effective their work can be.
Kelly, I want to tell you about this vehicle. This vehicle was built in May of 2002. It went overseas the beginning of 2003. There were actually 5 soldiers riding in this vehicle. It was a lead vehicle in a convoy. They were going down the road, and all of a sudden, boom, hit a mine. After the incident, the gunner had a few stitches in his head from a piece flying off the engine. The guy had a little scrape on his leg where the blast concussion come back. Other than that, they all walked away. They survived. The gentleman that was on top, the gunner, come in, told his story, thanked everybody.
All this damage occurred from one blast, and the 5 guys that were inside were protected because of the armor.
Yes. They estimated this mine about 4 times what the vehicle was designed for. So it was a big mine blast.
That's impressive.
Standard chassis built by AM General in Indiana arrive here in Ohio for the transformation. The plant is divided into work cells, each performing a different operation. The Humvee picks up a new layer of protection at each stop. A clock sets the pace and signals when it is time for a line move. Before 2003, Armor Holdings up-armored 30 Humvees a month. They've increased capacity to 650 a month, and, if necessary, could increase that to 1,000. Each of these vehicles will soon gain 2,000 pounds of armor. That means a new roof, new underbody, and new doors. Now that's a process worth a closer look. Check out the intensive labor involved here. First, they prep the door frame with a little grinding. A crane helps move the 200-pound door into position. Then, it is secured with bolts, rivets, and get this, glue. An adhesive so strong that if you removed all those rivets, that door would still be just fine. Every system on this vehicle is overbuilt. With 41 work cells and 25,000 square feet of space in the factory, I was glad Ron had a golf cart for our tour. Most of these vehicles are headed to the desert. That means monster air conditioners are needed so crews can work with the windows closed. Trust me, there's more protection with those windows up. That ballistic glass is almost as strong as the armor. And the machines that manipulate the glass, well, they're tough too. Those suction cups pick up more than half a ton of glass and move it around like it's a piece of notebook paper.
So you've just seen him move a 600-pound pane of glass, a single pane of glass, onto his work table, which actually turns out to be a lot like an air hockey table, because that 600-pound piece of glass is floating on a bed of air. He can move it around with one hand. Now, the machine is etching the glass to the specifications needed to make the windows in that up-armored Humvee. You gotta admit it, this is really cool stuff.
And you also have to admit Armor Holdings' commitment goes way beyond the factory. When the Humvees arrive at their destination, team leader Stu Schlichter is there to set them up and get feedback from the end users.
I was over there. I spent 6 months over there last year, talked to several soldiers, soldiers that were actually in our vehicle when they hit a mine strike or an IED. You know, just basically wanted to shake my hand and thank me.
Why do these vehicles perform so well? Quality control. And that requires constant evaluation.
This is where we test our glass and the armor components.
And by test, you mean like fire stuff into it?
Live fire, yes.
Where's the rifle?
There's no rifle. We have a barrel, and that's what we use.
Okay.
Ballistic testing manager Keith Blessinger demonstrated the technique. The round is placed in the chamber. A breech block is screwed on. Inside is an electromagnet, which acts as a hammer to fire the slug.
Now, call me crazy, but we're in Ohio. Why don't you just take a rifle and fire it into the glass?
The purpose of these rounds is that we actually load different amounts of gunpowder into the same round. And sometimes we exceed the maximum allowable pressure in the gun to the point that it would just destroy any kind of a breech if it were a normal gun.
They push each test on glass or armor as far as they can, right up to the fail point, further than what they expect to see in the field.
Now what I'll do is I'll fire the button. You may want to cover your ears.
Okay, thanks, Keith. Still hear that through the earpieces.
Right.
I wouldn't have believed it if I hadn't seen it for myself.
Ron, it looks like the slug is still embedded in the glass.
It sure is. That's the way the glass is designed.
Well, this is basically the thickness of what's in the front windshield of the Humvees.
Right. Also, you can feel the backside, no impact. That means the troops that are inside are safe. All the glass is coming to the outside.
We saw all that glass blow outward, and our troops are safe. This is fantastic stuff.
It sure is.
Speaking of fantastic, coming up, a machine that cuts through armor plate with just a blast of air. And I get to the bottom of things. Millions of M16s have been made. Later, how they do it. When GI Factory continues. You're watching GI Factory. We're in Cincinnati, Ohio, making Humvees rougher and tougher by adding an extra ton of armor in the form of a new roof, underbody, doors, and bulletproof glass. While a lot of the work on these vehicles is done by amazing machines, some parts have to be fabricated from scratch. And that's when an expert welder steps up to the plate.
Jim is one of our welders here. He went overseas in the military to do his service, and now he's back here.
Hey, it looks like he's still doing his service to the country.
He sure is.
And when real brute strength is required, they call in the big gun.
Now, Ron, what is this complex machine we're looking at here?
Well, this is a Whitney plasma and punch. It'll cut and punch all the way up to half-inch thick armor. Mick is the operator of this machine, and right now he's cutting underbodies.
I would have sworn that was another laser, but Ron explained how a plasma cutter works. Air is forced at high velocity through a constricted opening and zapped with electricity. The result is a temperature so high, the supercompressed gas becomes a new state of matter. Scientists call it plasma. And that plasma can cut through almost anything. It's mind-boggling. Armor that is tough enough to withstand a bomb blast is being cut by a blast of air. Whether built by hand or machine, each piece of the Humvee faces rigorous inspection. Here, a laser scanner, accurate to 1/1000th of an inch, compares this weapon mount with the blueprint in the computer. Each and every part must match the specs exactly.
I turn on the laser, and it shows the scan down here. That's actually a model of the part.
And that fits right on where the kind of the map.
We lay the part right in there. And I'm going to run this kind of slow.
Well, wait a second. This is a laser, right?
Yeah.
How about if we try this with the lights off and see what it looks like?
That'd be cool.
Go
Hit
ahead.
the lights for us. Okay.
This is a medium speed.
Oh, it tracks the exact
Basically-
outline of it.
Basically, it tracks the outside line of the part. It'll check each of those holes and show where they are in relation to what our print calls out.
That's medium speed. What's fast speed look like?
The laser show was illuminating, but what counts here is results.
And it's completely done. And as you can see, this is a good part. We'd actually print this out, and then that'd be our documentation for the government.
If we would lay this up on the table and do this by hand, it would probably take 45 minutes to check this part.
Time for me to do some inspecting on my own.
Kelly,
Yeah.
what are you doing?
I'm checking out this amazing armor you got under here that actually keeps people safe from anti-tank mine blasts.
That's classified information. I can't tell you
Oh,
about
roger that. We're not giving away classified information.
After all the armor is in place, it's time for the beefed-up vehicle to go to the paint booth. But as anyone who has tackled a painting project knows, most of the work is in the prep. That means a lot of tape applied in all the right places.
These are the vehicles that come off the line last night, and they're in prep to go in the paint. Right now, we'll run 30 vehicles through paint today.
They use two colors of paint, camo and tan for the desert, and darker green for vehicles headed for jungle operations.
Kelly, this vehicle just come out of the paint booth. It took them 15 minutes to spray it and a 30-minute drying time.
Can I touch it?
Sure.
Oh, it's rough.
Yes, this is a cart paint. It's a military paint. It'll withstand a chemical wash down.
So that's a little different than the paint on my Ford Mustang, huh?
It sure is.
All right. So it's been 24 hours since we saw that raw chassis come rolling into the center here, and this is the final product. But nothing leaves here until this man says so. Damon Burton, tell me what you do.
Well, my job here is to make sure that the truck is complete, all bolts are tight, and that the paint is good and ready to roll out the door.
So you're the final QA before this sucker rolls out the door?
That's correct.
There are 320 points of inspection for each truck. From tires to tailpipe, everything must pass muster. That all-important air conditioner well, it gets 4 different checks. And when the up-armored Humvee is certified 100%, it gets a yellow tag.
It's very, very honoring to be in this business, but you also have a bit of humbleness that it brings to you. Because as we touch these vehicles and they leave, we know that there's someone's son, someone's daughter, someone's father who's inside this vehicle who's going to be protected and return home. So it's really a humbling act to be here.
I want to thank you personally.
Thank you very much.
On behalf of everyone here at Armor Holdings, we'd like to thank all the men and women of our armed forces for keeping our country safe.
Coming up, a how-to on helmets. And I try my hand at making one. But first, we go to the factory where they make a legend, the M16 assault rifle, one of the most important combat rifles of modern times. Welcome back to GI Factory.
Since the 60s, the M16 has been the assault rifle of choice for the U.S. military. I carried one, my troops carried them, and today's soldiers carry them. We're in Columbia, South Carolina, and we're going to see how they make the M16.
The M16 was first introduced in the Vietnam era to give infantrymen a weapon with rapid firepower and a gun that was light in weight. With a 30-round magazine, it is just under 9 pounds. It rapidly became the U.S. military assault rifle of choice and has remained so for nearly 40 years.
Most soldiers will compare any other weapons they're using to an M16. It's a weapon that generations of soldiers have used since Vietnam. Every time they pulled the trigger, they expected something to happen.
The reliability of the M16 is the responsibility of the folks here at FN Manufacturing. The M16 is made up of over 100 parts, but it is essentially 4 sections. The buttstock, the upper receiver, the lower receiver, and of course, the barrel. To show us how the M16 is made, I met with engineer Randy Delk.
Kelly, in 2 days, this is going to be an M16 barrel.
That's a rod of alloy steel, durable enough to withstand the pressure, heat, and stresses an automatic weapon can create. That alloy combines the strength of 3 metals: chromium, molybdenum, and vanadium.
So Randy, you're telling me this machine's drilling holes in those gun tubes?
That's correct.
What do you use to do that? It's got to be something super strong.
This right here, we're using a 48-inch long special designed gun drill with a carbide tip on the end of it, which allows to help for a lot of chip relief as that's going into a blind hole. We have a lot of high pressure oil going in there and everything, and these are specially designed to help deep hole that gun hole.
At this point, the barrel is bored out to just under 5.56 millimeters, a touch smaller than the bullet it fires.
Next step of the process is we are now going to ream the barrel. This is basically enlarging the barrel a little bit more after we just got done gun drilling it, so that we can further it down the process. Right now what he's doing is he's loading the reamer into the barrel. The reamers are designed so that we're able to flow the oil through the rod, so that'll help ensure that all the chips are flushed out as the reamer is being pulled through the barrel.
So that there's nothing left in there.
So that there's nothing left in there. Gives it a nice smooth finish.
So all that oil shooting out the end is the pressure of the oil coming through while the reamer's being pulled through the barrel.
Correct. The reamers are now being drawn through the barrel, and all the oil is now flushing out all those chips. This is a rifled button. This is inserted into a barrel which is full of grease, and it is pushed through that barrel. And basically what's happening is it's called displacement. Right now you're currently going to see a finished 5.56 barrel.
Anybody who has ever carried an M16 will tell you the cardinal rule is keep the weapon clean. And guess what? It starts in the factory.
And now that that process is complete, you now have a 5.56 bore and rifle.
Now what's it doing?
Basically what he's doing now is he's just cleaning the barrel out of all the grease that you just saw right over here. Because he's cleaning it to make sure that the bore and rifling are good size and the twist is correct.
He's getting all that synthetic grease out.
Exactly.
To speed up manufacturing and maintain precision, many of the key processes are done using high-tech automation.
Randy, this is an impressive machine. What's it doing?
Basically taking that raw blank that you and I saw in the last process and turning the outside contour.
How long does it take for that?
About 3 minutes.
3 minutes and you completely transform that barrel.
Completely transformed it into this shape right here.
I can pick this up?
Yes.
Wow.
Now it's time to get that shiny barrel down and dirty.
Now, Randy, I know that's not a big vat of soup. What is this?
No, that is correct. This is our phosphating tank. Basically what we do is we submerge this nice shiny barrel into this tank for a half hour at 198 degrees. And it comes out looking like this.
Why do you want it to look like that?
Well, basically it's a rust protective, and we don't want our military troops walking around with something that looks as shiny as that.
No, that's right. You gotta have camouflage.
Gotta have camouflage.
How long for an order of fries in there?
About 30 seconds.
While I wait for my order of fries, the barrel is quality tested to make sure it is perfectly straight. Line Supervisor Brian Cox explained to me how exacting their standards are.
We hold our barrels within 3,000ths run out.
This instrument has a gauge that can read even the slightest variation in the barrel. If it is not up to spec, the barrel gets adjusted with a little bend and then rechecked until it passes. While the barrel is put through its paces, Brian takes me to see the manufacturing of the lower receiver. This part will house the magazine and trigger mechanism.
What Wayne is doing here, this is the first step in the process of the M16 lower receiver. It's made out of 70-75 alloy aluminum.
Why do you use that?
It's very durable, it's very lightweight, and it's easy to machine.
The machine is loaded, doors closed, and it does its magic.
I love this factory. The problem is the equipment's so high-tech you can't see what's going on. For instance, like right in here where they're machining the tool, there's a whole bunch of soaping lubricant. Keeps it cool, keeps the machine from breaking down. Means we can't see what's going on, we can only see what comes out.
And 20 minutes later,
He blasts that air to remove the coolant that's left and to clean the contact so that each piece fits exactly the same way every time.
this is what the receivers look like when they come out of the soapy mess. Wayne cleans them up before they move on. Many of the folks who work here, like Joyce Taylor, have extra incentive to produce perfect guns every time.
I have a cousin that's over there right now. That's why I do my job as carefully as I can. I think about him all the time.
Like the barrel, all M16 components are double-checked for accuracy and reliability. This computer-guided device measures coordinates on the receiver and compares them to technical specs. With this kind of technology, every M16 comes with a guarantee. As each element passes the rigorous testing, it gets sent on for assembly. We'll show you how the M16 is assembled and how it works.
I remember that smell.
Next. You're watching GI Factory. Columbia, South Carolina is home to FN Manufacturing, the outfit that builds the M16. We've already seen how the parts are machined. Now it's time to see how this awesome weapon comes together.
This operation is where we put the upper receiver onto the barrel. The first step is torquing the barrel nut onto the upper receiver, and we'll check for alignment of the gas tube as well. Now, there is a torque requirement, a min and a max, that can be torqued to the upper. Once that is straight, then he'll put the compensator on.
This piece compensates for the upward recoil movement of the muzzle. You know, keeps the barrel steady for the next shot.
Using a crush washer to align it to the specification built into the gauge.
As always, nothing moves on until it's tested.
That's correct. Then he'll check the true position to make sure that the center line of the upper receiver and the center line of the front sight to the barrel is aligned correctly. If that's bent, then we have to start that process all over again.
The M16 is starting to take shape, but with over 100 parts, this is not a job that can be rushed.
The next operation is to put the pistol grip and the buttstock assembly together.
It's starting to look like the back end of the gun.
There
now,
you
huh?
go. There you go. That's also
The grip and buttstock are made of polymer plastic. The pound or two you save makes a big difference to the soldier carrying it.
make sure that everything works properly.
The M16's rate of fire is 800 rounds a minute. To achieve such rapid fire, it needs a bit of help, which comes from pressurized gas.
So let me get this straight. When a round fires out of the M16, part of the gas that's released is recycled back to push the bolt carrier back and to recharge for the next round.
That's correct.
So basically, one shot sets up the next one.
That's correct.
Today's M16s are designed to fire in two modes, single shot or in a 3-round burst.
What do the hand guards do? You said a heat shield?
Yeah.
Keeps your hand from getting hot because the barrel is hot?
Keeps your hands from getting hot. Also has your 50-penny rail, which is this rail right here that you can add flashlight, soap, any accessories necessary that the soldier needs.
Getting closer and closer.
Almost a complete weapon, huh?
Now there are just a few final touches left until the M16 is finished.
He'll install the upper receiver to the lower receiver. He'll lubricate it. He'll install the charging handle and the bolt carrier assembly. He'll close the upper up. He'll charge it a few times. Make sure everything works correctly. Then he'll check trigger pull. You got a max and a min on trigger pull as well. Once he finishes there, he'll put a lifesaver in. We use these lifesavers just so everyone knows that there's no rounds inside the chamber.
So safety is a big concern.
Big time concern. And
now it's a weapon that can
now
fire.
it's a weapon.
And that's what I think I
That's
just
what
heard.
you just heard.
The M16 is finally assembled, but there's one more crucial test.
Certainly every time a weapon leaves FN, we need to be confident that we've done everything we know how to do to ensure the reliability of the weapon. Everything that we build goes through a full battery of testing, not only including the actual firing of the weapon to make sure rounds come out of the muzzle, but we look at targeting, we look at accuracy, we look at the round count, we look at to be sure that it's doing everything that it's supposed to do to meet the expectations that the end user will have.
At last, the moment I've been waiting for, to test fire the M16.
Pull the charging handle back. Push up on the
Only problem is, I haven't fired one since 1992. So I wasn't real sure what it was going to feel like.
All right. Yeah. I remember that smell.
At this indoor range, weapons are mounted for firing, never handheld. They have to be stable and consistent since accuracy is also being measured. To qualify, the M16 must hit the target at 100 yards with only 4 inches of variance. Firing range leader Rudy Fisher has a very personal reason to make sure these weapons qualify.
I have a son who was in the United States Air Force, stationed in Iraq now. When he first got his M240 machine gun from FN, he went and took it out at range and qualified with it, called me back and said, "Dad, y'all make a real good gun." I said, "Son, I know we do." And we just, our conversation, we started talking, and he gave me the serial number of that gun. I come back to work the next day, check it up, and lo and behold, I was the one that qualified that gun. So yes, it's very personal.
Where is your son now?
He's in Kirkuk, Iraq.
Well, let him know we wish him our best, and we hope he comes home safely.
Thank you.
FN Manufacturing makes and ships up to 4,000 M16 rifles a month. Look carefully and you'll find the serial number. Look closer and you might find the fingerprints of the more than 540 people who built it.
Brian, you know, I carried one of these for so many years and thought I knew a lot about it, but after today, I realized I didn't know anything. I want to thank you for being such a great tour guide and for teaching us a lot about the M16 and how it's made.
Well, it's my pleasure. We take a lot of pride in manufacturing this weapon, and it's just our small part in helping the soldiers in the field.
Thank you.
You're quite welcome.
Coming up, what the well-dressed soldier wears. I'm sorry, what every soldier wears. And of course, how they make them. Next on GI Factory.
We're in Scranton, Pennsylvania, heart of the Poconos. Ski country. Well, not today. It's an unseasonably warm winter day here in this gorgeous residential neighborhood. And what do you think we found here? A factory. A factory that makes one of the oldest pieces of equipment known to the military. For thousands of years, soldiers have been using the helmet. Welcome to Armor Holdings.
In the past, soldiers wore helmets that were short on comfort and protection. They were basically thinly padded metal pots that could only stop slow-moving projectiles or small fragments. The new generation of helmets is lighter in weight, just 3 pounds, while still delivering high-performance protection. Designed for comfort and using the latest technology in ballistic composite construction, today's helmet is a whole different story. The reason? The raw material is fabric. That's right, it all starts with these sheets of Kevlar, the most famous brand of polyaramide. It's a super tough synthetic cloth. Bill Traynor, the plant's manager, is the man who will take us through this amazing metamorphosis.
The woven fabric is coated with a resin that allows it to be molded and formed together with heat and pressure.
A computer-controlled cutting machine slices the sheets in precise patterns, unique to each model and size. Today, they're making the Advanced Combat Helmet, also known as the Warrior.
Right now, this machine is cutting through 20 layers of that material.
Wow.
The actual cutting takes place with a reciprocating blade, which you see moving in that head, and it does allow us to be able to cut material very efficiently.
The patterns are programmed into the computer to guide the flying blade's movement.
But no matter how high-tech you get, you still need human hands pulling the material off the end of the line.
Bill had all the cut pieces laid out for us so we can understand just how many elements go into making these helmets.
Kelly, believe it or not, we are looking at the pieces to make 20 helmets here. And an advanced combat helmet is made up of 130 of these pieces.
130?
Yes.
Wow.
And it takes about 2 days to process these through our operation.
The panels need to be cleaned of excess fiber, which results in what looked to me like a heap of fluff.
Well, what's all this fuzzy stuff right here?
Well, that fuzzy stuff is what we call around here the key to the performance of the helmet. It is actually the fiber that is of an extremely high tensile strength that used in the fabric weave allows the helmet to perform at the level that it needs to.
Stopping bullets, saving lives, and keeping our soldiers safe. That's what this is about.
The fuzz-free flaps, as they're called, are then pressed at 150 degrees, bonding them to larger panels. Slowly, the pieces of the puzzle will become a combat helmet. The next challenge is to accurately sew the various parts together to create what they refer to around here as a rosette. The finished rosettes are taken to the preforming machine. More than 30 layers are piled on top of each other. This multi-layer design is what gives this helmet its amazing bullet-stopping capability. Early helmets were all about deflecting the slug. Today's design catches it. The round's kinetic energy is absorbed and distributed throughout the many layers, thus weakening the impact. Here's a bizarre photo to illustrate the point. That sheet of Kevlar trapped the bullet and spared the goldfish. That's what the helmets do. Liquefied resin is applied to the seams to ensure the consolidation of the layers. This machine's 180-degree heat fuses the layers together. When the rosette emerges, it is starting to look more like a helmet, assuming you think a helmet looks like a flower pot.
Kelly, this is our molding operation.
What do you guys do in molding?
This is where we take the preform and we apply high pressure and high temperature to consolidate all the parts.
So you're taking that kind of artichoke piece like this and turning it into a final one-piece helmet?
Yes, that's where we get our completed shell.
The preformed shells spend 20 minutes in the molder at a toasty 350 degrees. It's an incredible machine, and kind of reminded me of the contraption that created Darth Vader's ominous headpiece in Star Wars. In a couple of hours, the sheets of flimsy fiber have been turned into a rock-hard shell. All that is necessary now is a little tweaking. I asked Fred Sweeney what goes through his mind while operating his station.
I think my job's important. It saves lives. I was in the Army. I know what it's like to wear something heavier than this. It's a lot lighter and it'll protect you better. It's an important job. I'm glad to do it.
The Advanced Combat Helmet here at Armor Holdings is a combination of manufacturing helmets for over 30 years, coupled with commitments to engineering and design resources, and marrying up the latest in technological advancements in materials. As a result, we've been able to create a lightweight, highly performing ballistic helmet. And quite frankly, at the risk of bragging, I'd say it's the best helmet in the world today.
Holes are drilled in the shells for the chin strap that will be added down the line, and for a night vision mount that could be added in the field. Even after careful trimming, the helmets still need a little more grooming. Those rough edges are hazardous and have to go.
We're here where they apply the rubber edging to the helmets. I'm watching Chris work his magic on this helmet. Chris, what are you doing now?
Right now I'm applying an activator that helps the glue to stick. Helps the rubber edge to stick to the helmet.
Now, I know you're an expert at this. How long does it usually take you to do a helmet?
Approximately 3 minutes.
What are the chances I could do it in under 5 minutes?
Be my guess.
A vacuum holds the helmet down so you can use both hands. It might seem easy, but Bill tells me of all the jobs in the plant, this one requires the most dexterity. Okay, we'll be here all day unless I speed things up. But even with all the extra time it took me, the outcome was, less than satisfactory.
You know what? There's troops waiting. You're fired.
Oh, that's gonna leave a mark. Thanks a lot, Chris.
Kelly's will not pass quality control. Don't worry, soldiers. I'll redo it.
This step is very important. That rough, unsealed edge could cut a soldier. And it's porous and would absorb damaging moisture. The rubber blocks rain and snow, plus it guards against wear and tear. I guess that's why they leave the job to the pros.
Now, Bill, I've seen a sandblaster before. Why are you guys sandblasting helmets?
There's actually two reasons. One is to remove any of the excess mold release agent that may still remain on the surface of the helmet.
Let me guess the second reason. Because you got to smooth it and polish it out.
Actually, it's just the opposite. It's to prepare the surface of the helmet and mat the surface so we get better paint adhesion when we go to paint it.
Really? Do you mind if I hold one?
No, would you mind?
Thanks. Oh, okay, I see what you mean. So the paint will stick to this better.
Yes.
Can we go check out how you paint them?
Sure.
Hey, thanks a lot. So, Bill, what kind of paint is this? This is like what I paint my house with?
No, not really. It's a very durable paint that has a catalyst that requires it to be cured out. And also we mix in the paint a walnut nutshell to give it some texture.
All Army helmets are painted in this color with the picturesque name Foliage Green 504. Of course, it will be hidden by a camouflage helmet cover in the field.
4 hours for the first coat, 24 hours for the second coat. We've got a lot more exciting stuff to do than watch paint dry. Come on.
If your helmet doesn't fit right, you can't fight right. So here they are adding the retention system, a fancy name for a chin strap. And it's a unique design. If it should get shredded in the field, it's easy to swap out. Comfortable foam pads are attached to the Velcro circles to ensure a snug and secure fit. Now we know how the helmet is made, but the big question is, how will it perform under fire?
Kelly, this is where we do our ballistic testing. We've got Matt preparing the shot right now. The government, under each one of our helmet contracts, requires us to do lot acceptance testing.
A lot of companies are kind of nervous about the government coming in and inspecting.
Well, we're not. We're actually over 150,000 shots fired without a failure.
Wow.
Charge ready. Great. Let's put it in the chamber.
This 5.56 bullet will be traveling at 1,700 feet per second when it hits the helmet. Sensors on these screens measure the speed.
The results of the test will be recorded here. What you have is the size of the fragment that we're firing, which is 17 grain hardened steel, the powder charge, which is at 8.8, and the velocity at which it goes downrange. And right now, Matt is making sure that we are meeting all of our safety protocol. We've got double locking doors here. He's checking that all the lights are in the on position, and he will now fire the shot downrange.
Fire in the hole. Let's go take a look and see if you pass the government inspection.
Let's go.
All right, Sean, we're at the moment of truth. I want to see how the helmet held up. Okay, this is where it went in, right? The fragment went in right there?
Yep, that's correct.
And let me feel inside. It doesn't feel like anything penetrated the helmet. Tell me what happened in scientific terms.
Well, you're right. The fragment entered the front of the helmet here, and actually the helmet performed exactly as we would have expected it to. We've got minimal deformation here, and there's nothing in the witness plate.
Well, by my count, that's 150,001.
That's correct.
Congratulations.
Thank you.
From fuzzy fabric to high-performance headgear in just 48 hours. Combine smart design and a hard-working factory, you get a state-of-the-art helmet.
Bill, you've been great today. You have opened my eyes about all the technologies that are involved in this helmet. Armor Holdings has been great. I want to thank you for all you've shown us.
It's been a pleasure having you.